Hi, good morning. I want to talk to you about multiplying binomials today and go over a couple of rules with you. So the first rule that I want to talk about is when multiplying like bases, add the exponents. Keep the base the same. So let's talk about what that means. If we have monomials, first of all, a monomial is a variable, a constant, or a product of variables and constants. So even if you have the number 2 is considered a monomial. And the letter x is considered a monomial, and then you put it together, 2x is considered a monomial. So let's see here, when multiplying like bases. So if you have an x to the third power, and you're multiplying it by x to the fourth power, we have a total of 3 x's here and 4 here. So when you want to find out what the product of those two monomials would be, you want to add the exponents together. Now this last part, it says keep the base the same. So whatever, this is the base. So whatever the base is, it stays the same. And then you add those exponents together. 3 plus 4. So the answer is x to the 7th. Okay, right there. So sometimes we have situations where the exponent is a 1. I want to talk about that situation. So when multiplying like bases and you don't have an exponent, you're going to have an exponent of 1. So let's say we have x times x to the third times x to the fifth. Well, if there is still one factor of x here, and it's understood that there would be one factor. So if there's not an exponent, you can tell that it's going to be a 1. And so then you go ahead and you add all of the exponents together because the bases are alike. So x to the 1 plus 3 is 4, plus 5 is 9, x to the 9th. So this is a rule for when multiplying like bases. Okay, now the next thing I want to go over is what do you do when you're multiplying monomials, but you have more than just variables in the problem. You might have a coefficient. Now, if you remember, a coefficient is a number that's in front of a variable. So when multiplying binomials, find the product of the coefficients and use the exponent rule to like variables. So we're going to use this exponent rule, but we're also going to make sure we know what to do with coefficients. So let's say we have 3x to the fifth times 2x to the third. Well, you're allowed to use the associative property here and the commutative property and regroup these. So we can rearrange the products because multiplication is commutative. So we can take the 3 times the 2. Those are the coefficients. And you can find the product of the coefficients. And then the x to the fifth times x to the third can be the second thing that we do here. So 2 times 3 is 6. And then 5 plus 3. We're using the exponent rule for like bases. So 5 plus 3 is 8. So 6x to the 8th. Okay, let's try another one. Let's take 4, let's make it negative. Negative 4 x to the third times 2x, and then maybe we just have a negative x, and yeah, let's just leave it at that for now, negative x. Okay, so our coefficients in this problem is a negative 4, a 2, and here you see a negative sign. Where you see a negative sign, you're going to put a 1 because that means that negative 1x. So let's rewrite this. Let's regroup the coefficients using the commutative property. Negative 4 times 2 times negative 1. Let's rewrite x cubed times x times x. So x cubed, x, and x. And we said if you have an x by itself, its exponent would be 1. Actually have two of them there with an exponent of 1. So your answer is going to be the product of these numbers. Negative 4 times 2 is negative 8. Times negative 1 is 8. And then you're going to add the exponents together. 3 plus 1 is 4, plus 1 more is 5. So 8x to the 5th. So today there's some problems that if you look at the last slide, and it'll give you some an assignment for what you're supposed to do next. Thanks. Have a good day.